lines and shapes, understand the effects of these transformations, add a little bit of vocabulary in there. Any questions, comments, side remarks, jokes? All right, here we go. Here we go. Yes, I have big ears. All right. It's not shocking. All right, here we go, guys. A transformation is a change in the position, size, or shape of a figure. When you go through a transformation geometrically, that's what you do. Okay? You change position, size, or shape altogether of the figure. The original figure is called the pre-image, and the resulting or transformed figure is called the image. I don't know why we don't call it an image and a post-image. I don't make the rules. Don't make the player a game. It's the first time I've got a secret all day. All right. You'll notice on your pre-image includes the capital letters A, B, and C. And then there's a big arrow. We call that arrow notation. And then it says A apostrophe, B apostrophe, C apostrophe on the image. We call that A prime, B prime, and C prime. So you go, when you do a transformation from A, B, and C to A prime, B prime, C prime. Or you could go X, Y, Z, X prime, Y prime, Z prime. Or you can do 3 or 4 of them at a time. A double prime, C double prime, D triple prime. We're not really going to do that. But it's out there. Yeah, I was excited. Okay. We'll go for about 20 more seconds on this one. Ooh. You know what? Yeah, it would help. I'm not going to make. I'm not going to physically pick up the pencil. Make you do it. Okay, that'd be a little disturbing. My sweet label is. All right. Next, don't come back to it if you need it. Oh, good, because here's why. The 3 transformations we're going to be talking about today are reflections, rotations, translations. No, I don't mean habla español. Do you speak Spanish? Okay. Let's go, man. All right. You can just glance at the examples. If you need to write them down, you can. However, these definitions are a must. Must write these down. A reflection or a flip is a transformation across a line called the line of reflection. Each point and its image are the same distance from the line of reflection. Please make careful note of the word flip. Yes. What? Break them down. Make them like smaller. Sure, man. Your notes, how you do your notes. It's like looking at a mirror. Just like it. Alright, guys. When I say trigger word, I got a hint for you. Your trigger words are going to be very key on the quiz on Thursday. So make sure that you write down the words that I circled in green. Okay? Because they're going to be key on Thursday's quiz. I know the guy making the quiz. He says they're key. I trust him. But you can move up.
You sing that ESP commercial? Which guy always says it's his birthday, so iPad goes off. You know, he's like, I get back talking. I talked to John personally. I talked to John. Shoulder should be okay. I texted his buddy. I know.
When something reflects reflects, it flips. It flips. Okay, reflection is a flip. It can go across the x-axis or the y-axis. If it goes across the x-axis, it's going to flip top to bottom or bottom to top, right? That would be across the x-axis. If it goes across the y-axis, it flips left to right or right to left. Oh, ingenious, you say. I believe so. Greeks knew what they were doing. I don't even know if it was the Greeks, but we're going to pretend like it was. A rotation or a turn. A turn, like a rotation. A rotation is a turn about a point P, which is called the center of rotation. Each point and its image are the same distance from P. So if I tell you something rotates, what does it do? It turns. Do I have any turn fans in here, by the way? Turn, AMCs in the spring, Washington Spies, Abraham Woodhall. Anybody have television that they watch anymore, or am I just the only history nerd in here? Well, then you should watch Turn, although it is probably rated for adult audiences. Right, last one. Nope. The translation. The translation or a slide is a transformation which all points of a figure move the same distance in the same direction. So does the roster. What does the translation do? It does what? Slides, right? All right, guys, check it out. It's going to slide left or right, up or down. Okay? Slide left or right, up or down. So, how did this particular square translate? It went to the right and then up, or it went up and to the right. Okay? Let's make sure we got a trigger word down. I say reflection, you say the trigger word. Reflection. Trigger word. Judging our level here. Okay, we'll try this again. Not necessarily the phrase trigger word. Just tell me which one to associate with. Reflection. Rotation. Translation. Okay. Flips, turns, slides. Not last we had a game. I can't tell you the name of the game, but you can think of it like this: flip one, turn one, slide one. Okay. What you gonna do? Identify this transformation and use the arrow notation to describe what happens here, all right? You got to flip one, turn one, slide one, all right? What happened here? What did it do? It turned, right? It turned on me, all right? All right, so some people probably said, no, then it reflected. No, it did not reflect at all, okay? It just turned. Right? And if you're like, well, Mr. Hunt, what happened was it slided this way, and then it slided down, and then it slided around. Okay? Well, remember that around part is called turn. All right? So, this is a rotation. Rotation. When we talk about rotations, okay, there has to be that point of rotation. In this case, it's the origin. All right? When they rotate this triangle from A prime, B prime, C prime, I'm sorry, from ABC to A prime, B prime, C prime, they rotate it about the origin. Right? That's what we're going to be working on today. Okay. Next, what happened here? I tell you what. We'll do a little interactive folding here. One, this is a reflection. Two, this is a translation. Three, this is a rotation. Okay? Take a couple seconds, look at it. Look at the details carefully. It's all in the details. Devil's in the details. Okay? See some people that are shouting out one, some people are holding up one finger. And people are like, dude, what's a reflection? Okay. When I say reflection, what do you think of? Smear. Hey, what's the trigger word that goes with reflection? Good. All right. Remember, you got flip one, turn one, and slide one. Okay. So what we do here, we went from D, E, F, G to D prime, E prime, F prime, G prime, and we reflected across which axis? X-axis. If we had reflected across the Y-axis, this here figure would have ended up over in this here quadrant, right here, right? Y'all got me? Okay, so here, the reflection. Last one. Let's go interactive. Get out those phones again, classlab.com. I want this to restart, start it up. Okay. Tell me, you can text it, please. Tell me what type of transformation this is. Is it a reflection? Is it a rotation? Is it a translation? Or is it a dilation? It's not a dilation. What's Did you text that to me? Because that's what I was hoping you would do. But if you didn't text it to me, and you're not like, I don't, it's TYL. Nobody TYL. Water. There we go. Now we're getting to the table. Good on. Right on. Here we go. It is a translation. What do translations do? They slide. Okay? They slide. Translation, or slide. Very good, very good, very good. Check it out. My figure from MLP slid what? To the right and then down. Or down and to the right. Okay? It slid. It didn't rotate. It didn't reflect. It was merely sliding. Okay? Now, I didn't put this on a coordinate plane on purpose. Okay? I don't want to confuse us to begin with. If I put coordinate points up there, okay, if I put a coordinate point for M, let's say it was -4, 6, correct? I would say I want to translate this 5 units to the right and 2 units down, right? See that? If I put that on a coordinate plane, given it coordinate points, it would have said translate M, N, O, P, 5 units to the right, 2 units down. As an example. Okay? Hey, okay. We're done. Ooh, new word, isometry. Right? Big word, yeah, I know. 7 letters. Right? 8 letters, whatever. An isometry is a transformation that does not change the shape or size of the figure. Reflections, translations, and rotations are all isometries. Isometries are also called congruence transformation or rigid motion. The reason I circle that is because in this great state of Georgia, we talk about them as if they were rigid motions. And elsewhere in the world, I don't know, probably Iowa, North Carolina, maybe a state we don't really talk about a lot, Idaho. Oh, that state union. Okay. All right, so, Tyler, what are the 3 transformations we've talked about today? Reflection, rotation, translation. And of those 3, which one is an isometry? Yes, a translation is a rotation, is a reflection. All right, good deal, guys. All the transformations we talked about today are what we call rigid transformations. That means that whenever we apply reflection, translation, or rotation, the shape and the size of the figure does not change. Okay, we move it around, so to speak, but it doesn't change. Soon, coming up, we'll talk about another transformation called dilation. Dilations make things get bigger or smaller. Okay. Okay. All right. Now let's do another little formative assessment here. Check out what I've labeled there: A and B. Okay. The question's going to be which of those is an example of isometry, or isometry, or that word starts with an I. Okay. All right. Raise your hand if you've looked at them. How many of you think that A is an example of isometry? Right? Good. How many people think B is an example of isometry? Okay. How many people ain't got a clue and have yet to raise your hand? You know, it's what? Oh, very good. If you raise your hand, if your hand raised for A or B, you'd be correct. Both of these are examples of isometry, right? Did these shapes change? Did these shapes change? This one slid to the right, this one flipped, correct? Right? Y'all see that? The size didn't change, and the shape itself didn't change. Okay? Oh, you don't have to write this part down. This is how we will work out a translation. Define the coordinates for the image of the figure translation. Add A to the x coordinates for the pre-image, and add B to the y coordinates for the pre-image. Simple, right? Translation shall be described by rules such as x, y, arrow notation, x plus A, y plus B. All right, here is the fancy way of saying this. If I start at a coordinate point, I'll make it easy, 0, okay, and I slide, translate to the right 3 units. Where do I end up on the x-axis? Yeah, which from 0 is at what? 3. So here we go, ready? 1, 2, 3. I took my original x coordinate, which was 0. I added 3. My translation. Right? Okay. So if I started at 0, 0, and I translated 3 to the right and 2 up, I would end up at 3, 2. Correct? The harder one for you guys is going to be this. I start at 3, 0. I translate 4 units to the left. Would I add or subtract? I'm going to subtract how many? Right on. So some people get all scared about this. You don't have to be scared. Okay? We're not going to kill you. You might be wrong, but we won't kill you. All right, here we go. So I'm at 3, 0, and I translate 4 units to the left. I go from 3, 2, 1, 0, -1. Correct? That was 4 units to the left. Right? Correct? Okay? That was a slide or a translation to the left. Having said that, let's talk about this. Here we go. Read up on it. Find the coordinates of the image of triangle ABC after the translation x, y, x plus 2, y minus 1. Draw all that image. All right, here's where you can start. ABC. 1, 2, 3. Good. I want you to write out for me the coordinate points of A, B, and C. Remember, we call this the pre-image. Before my transformation. So I want the coordinate points of A, B, and C. You should be writing this down. Miss Bowen, I want you to write it down. I can't count. I got to count. Dakota. I don't have Dakota in here. Usually I got Dakota if I want to get on my. Name. What's your name? No, not you. Avery. Avery, where is A located? What point? Good. -4, 2. Avery, we're on a roll. Where's B located? Good. -3, 4. Avery, where's C? Right on, right? -1, 1. Now, check it out, y'all. Here's the translation, which means a slide, that I want you to apply in this problem. I want you to take those x coordinate points and add 2. I want you to take the y coordinate points and subtract 1. And you're going to do that for each particular set of coordinate points. Okay? Then I get my image over here. My image is my post for prime coordinate points for my 3 points on track. Let's do a little math there. Gavin. What's -4 plus 2? Gavin, what is 2 minus 1? I got it. Okay. Gavin, -3 plus 2. Good. Gavin, what minus 1? I got it. 3. 2 and 3. Gavin, what's -1 plus 2? Good. I got it. 1 minus 1, 0. Okay. So after I translate that triangle, these are my new or prime coordinate points. Yay! Which of course was up there the whole time. I don't know how you got that. All right, but there's how that particular transformation looks. I look at -2, 1, I get A prime, -1, 3, I get B prime, and 1, 0, I get C prime. Right? Questions on that? Pretty simple, right? Translations are pretty easy. That's all I got. Okay? You're welcome. All right.